Do you feel the vibes?
All right, so the past 2 days we've been talking about how to graph exponential functions, and we've graphed functions with several bases. Today we're going to graph functions that have a natural base. You might remember from Algebra 2 that the natural base is this number we call e, right? And e comes from something very practical. So here's where e comes from. A lot of problems that happen in real life, right? A lot of real life problems end up with a factor that looks like this: 1 plus 1 over x to the power of x. And often we have to see what happens to that at the very end, the end behavior as x approaches infinity. It just so happens that when you graph this equation, 1 plus 1 over x to the power of x, and you look at the graph of it, it starts off like this and then it levels off, right? Just steadily. That point that it levels off happens to be 2.718 ... That is the magic number that we call E. So E is known to be this number. It is a number, an irrational number similar to pi, 3.14, etc., etc. This time it's 2.718 ... Okay. This is the natural base. And so often we have to graph exponential functions with this base. Okay, so take a look at this first function. We're going to graph and we're going to do the asymptote and everything else. So here we have f of x is equal to e to the x. Now, we have to figure out if this is growth or decay. Well, this number e that's being raised to the x is 2.718. Definitely greater than 1, so this is growth. All right. Everything else will apply, right? Last time we had 2 to the x, now we have 2.7 to the x. There's really no difference. So the asymptote is still y equals 0 because there is no vertical shift. The y-intercept is f of 0 equals e to the 0. And again, anything to the power of 0 is 1, so it's just 0, 1. Nothing different. Okay. We said this is decay. We said this is growth. So let's just graph from -1 to 2. We're going to have e to the -1, e to the 0, e to the 1, e to the 2, right? Okay, some of these we can do. Anything to the power of 0, e to the 0 is 1. E, the value of it is 2.7. To the power of 1 is 2.7, right? No need to waste time on the calculator. Now, for the rest of this, we have to have our calculator. Because I don't know about you, but I don't want to do 1 over e in my head. So here we go. Here's the calculator. All right, so E is this button here to the left, the very left of the 1 button. E to the power of -1. There we have it. 0.367, blah, blah, blah. Okay, now I just round that to 0.4, right? Because when I'm graphing, there is no difference between 0.36 or 0.4. So there you have it. The next one, e squared, is going to be e squared. So you just do 2 equals 7.38, which is 7.4. That's actually a helpful number to know. All the cool people know e squared is 7.4. I don't know. Okay, so the y, so here we go. I'm going to choose red for my asymptote. So let's do the asymptote. Right? So here we go. -1, we're at 0.4, then 1, 2.7, all the way here, and then 7.4 all the way up here. My graph. And there you have it. Okay. Domain is always all real numbers. The range, again, we start at the asymptote and it's going up, right? So 0 to infinity. Okay. Let's take a look at this one. Okay. So the asymptote now, remember, look, there is a plus 3. So the asymptote is going to be y equals 3. In fact, why don't I put that up right now? There you have it. Okay, the y-intercept. E to the 2 times 0 plus 3. E to the 1 plus 3. Oh, no, not e to the 1. E to the 0 is 1 plus 3, so that's 4. So 0, comma 4. Okay, so what's going to happen here is the following. E to the 2 times negative 1 plus 3. Let's see how much that is. Okay, so e to the power of negative 2. And then look, I exit by pressing the right button plus 3. 3.1. Okay, e to the 0, I just did it and I got 4. E to the... Okay, so when I have 1, it's e to the 2 times 1 plus 3. What did we say e to the 2 was? That's 7.4 plus 3, so that's 10.4. You could obviously also put it in your calculator. And the next one is going to be above 10, so I'm not even going to bother. Okay, so at negative 1, we have 3.1, 4, 10.4. Okay, so I'm just going to put that right there. Don't say anything, okay? And there you have it. So the domain is always all real numbers. The range, this graph is sitting above the asymptote, so I start at the asymptote and it goes up to positive infinity. All right, so take a look at this one. The asymptote, y equals 0. Now look, there's a negative here, right? So this is going to be a reflection. The y-intercept, f of 0, is negative e to the 2 times 0, negative e to the 0, negative 1. Okay, so where's the asymptote here? 0. Let's put the asymptote first. Okay. Now look, for these, I'm going to show you something else as well. Okay, so let's go here. Why don't we go to the graphing window, right? And I'm actually going to just graph this. So negative e to the 2x graph. Oh my gosh, look at that. Look at how extremely beautiful that is. So now you can actually take values from the graph to fill in this table. So at negative 1, all right, so there are 2 ways to do this. One way is by trace. Menu, 5 for trace, 1 graph trace. And here, okay, I can type in negative 1, and you see here at negative 1, it's negative 0.1. At 0, negative 1, we knew that already. At x equals 1, negative 7.39. At x equals 2, oh, wait, negative 54.6. Okay, I really don't want that one, okay? So let's go ahead and graph these. Okay, so at negative 1, I'm at negative 0.1, then negative 1, then negative 7.39, somewhere over here. I graph this guy. Beautiful. This is what it looks like. Okay, the other way to have gotten these numbers is the following. Sorry, 1 second. Let me just get this back. Menu 4. I just want to press number 5 and get to the standard. Okay, so I'm here. Okay, you can do Control T to get the table. T for table. And now over here, look, you've got the values. So if I scroll up to negative 1, I got negative 0.1, 0, 1, and so on. I really don't care how you get your numbers, as long as you use your calculator correctly to get the correct numbers. Okay, domain, always all real numbers. That's free points. The range, right? So again, it's going to be connected to the asymptote, which is 0. This one is sitting below the asymptote, so it goes from negative infinity to the asymptote. Okay, last but not least, let's do this one. Okay, what about the asymptote this time? Okay, I hear some of you saying y equals negative 4, and you are right. Y-intercept, negative e. Okay, so let's do f of 0 is negative e to the 0 minus 4. This is negative 1 minus 4, negative 5. Okay, so y-intercept is all the way at negative 4. I'm sorry, the asymptote is all the way at negative 4. Okay, let's graph this thing. Let's see how we can do that. Okay, so tab. Let's go up. All right, I want to delete this. So negative e to the x minus 4. Ooh, right there. Okay, so menu. If you do trace, number 5, number 1, graph trace, look, it always starts at the y-intercept, right? So at 0, we're at negative 5. And then at negative 1, negative 4.7. At 1, negative 6.72. And then at 2, it's going to be negative 11.4. I can just feel it. Okay, so here we go. Negative 1, negative 4.37. Then negative 5, negative 6.72. Negative 11. I'm fine not graphing that. 3 is pretty good. And there you have it. Okay, domain, all real numbers. Range, again, we are connected to the asymptote of negative 4. This sits below the asymptote, so we go from negative infinity to negative 4. Okay, and there you have it. We will stop here today. You have another graphing worksheet to do, and I will stamp all of these homework when you get back on Monday. Okay, have a good weekend, everyone.
Press start.